Hello, I'm Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. We have been working with PixInsight and the workflow that I use when processing deep space images, and we're going to be looking at deconvolution. So let's head over to PixInsight and pick up where we left off. We had finished running the multi-scale linear transform tool to smooth out our image and do some noise reduction. So what we're going to do now is work on the Luminance layer, and since we didn't shoot Loom files, we're going to have to create our own out of this RGB image. And I realize that it's sulfur 2, HA, and O3, but they're mapped in the RGB channel, so I'll refer to this as the RGB image, and probably from now throughout the balance of this processing workflow of mine. So let's extract the Loom layer. And you do that by coming up to this icon and clicking on it. Let's stretch and see what we've got. We're going to park our RGB image for the time being, and we'll see what our Loom layer looks like. Now, one of the things that I've noticed about the my images in deconvolution, if I have some really good data, deconvolution works extremely well on my Luminance layer. But if my data is marginal, it doesn't always give me the results I was looking for. So I'm not sure what's going to happen here. I would say the data is okay, not great. Also keep in mind that this image was drizzled 2 times. So that will have an effect on the stars. Now, the deconvolution will have an effect on your stars, and it will also have some effect on your nebulosity. But where I notice the improvement the most is on its ability to tighten the stars and define them more clearly. So let's get started. It will require that we create 3 different masks. One's actually not a mask, it is a model star. So we're going to use the point spread function, the dynamic point spread function, to do that. There's actually 2 methods that I've been using, and I'm pretty much resolved to use this dynamic point spread function. Hartmut-Bormann created a script that is called the PSF image, and if you go to his website, it's actually not his website where the Hartmut-Bormann scripts are located, but I will look that up and put that information, add that information to the details description of this video so that you can find that script. But I'm going to run both of them, and let's go ahead and start with his PSF Image Creator 2.1.11. All you do, let me go ahead and all you do is click Evaluate with your opened image. Okay, the script has finished running, and as soon as it completes, you check Create, and here is the model star. Let me okay that. And so what I'm going to do is save this. It has a name, PSF, for point spread function, and I'm going to save that over here. And then I want to introduce you to the dynamic PSF, and the key to using this is to select stars that fall within a certain criteria. You want to look at the A column, and actually it's pointless to look at any other column. Hang on. It doesn't serve me in the creation of this model star to pay any attention to any other of the columns. So also down at the bottom I have auto checked and signed angles checked, and I think this is the default. Under star detection, the search radius is 8, the background threshold is 1, which makes sense. Anything over 1 would be clipped, and under scale model mode we have pixels selected. So, and those are the defaults, so you don't need to change anything. So here's what you do. You will use the Luminance Layer, and let's go on over here and give this a new name, call it Loom. And we're going to use this Loom layer and zoom up some. And we're looking for stars that fall within 0.2 and 0.8. Now, again, when you get to 1, you have clipping, and if you get to a minus, you have clipping. So anywhere between 2 and 8 will provide really the happy medium for star selection. So let's just click on that. Moffett and 0.40, and again we're looking at 0.2 as a low and 0.8 as the upper threshold. So that works, and you continue to look through these. And I want to show you something when here's a 0.48. Let's pick a big star. This will probably be Gaussian, and it is. You need to pick one or the other, and you want 20 stars for your model. Either pick Moffett or Gaussian, but don't combine the two. So I'm going to just hit delete, and I'll try this one, and this is 0.25. That works, and I'll come back when I have my 20 stars. Okay, I'm back with you. We have more than 20 stars, but as we look, they're all Moffett, and they all fall in the A column within 0.2 and 0.A. So what we want to do is select them all, and we'll go down and grab the bottom. Whoop, wrong key. And once you've selected them all, go down to the camera right here, click that, and here comes your star. And it is capital PSF for point spread function, so we can delete that. And let's save it. So we have from the Hartmut-Bormann script, and we have the dynamic point spread function from PixInsight. I want to take you over to the web page. That's some volleyball pictures I took. And if you go to skypixels.at, you will see the scripts by Hartmut-Bormann. And when you go down here, here are the scripts. I would encourage you to download Game, Autocolor, and point spread function PSF, which is, I don't see it, but it's here, PSF image. I have added those three, and we'll be using those today with this image that we're processing. So again, that's skypixels.at, and it is /pixinsight.scripts.html, but you can screenshot that and go to this website. All right, let's go back to our image. So we have the first key element in order to run deconvolution. Now we need a luminosity mask. So let's drag a copy over here, and let's put our Lum layer up here to rest, and we're going to call this Luminosity Mask. And in order to use this, we're going to need to run it through the histogram transformation and stretch it. So let's bring histogram transformation up. I saved the process, but if you'll go to Process, All Processes, and go down to histogram transformation, you'll find it here. And I want to make sure I have the correct Lum layer for the correct image that I'll be stretching. I'll reset it. I'm going to unstretch it, create a preview, and then I'm going to raise the slider up, execute, reset, bring the darks down, bring the highlights up, brights up, execute, reset. I'm going to bring the darks down, and keep in mind we're making a mask, so I want my stars bright, I want my nebulosity bright, and I want my background black. I want it clipped. I'm looking for a mask, not a pretty Lum image. So something on the order of this. And we're going to execute. I'm done. I like that mask. And we're going to move the luminosity mask over here. Actually, we need to do one other thing. I need a star mask, and I think I'm going to create my star mask out of this layer. I'm going to bring up StarNet, and I'm going to check create a star mask. Now I could use the star mask feature, which you can find under process, all processes, and come down here to StarNet, and also star mask to bring up these two possibilities. But I'm going to use StarNet because not only do I need a star mask, but I want a mask of just the luminosity, and so this will do that. So I will execute this process onto my image. It'll take it a few seconds. Okay, StarNet's finished, and we have a star mask. We'll set this over here, and we also have a mask of the nebula, and I'm going to work on that in just a minute because I plan to use this. I'm going to go up to Script, Utilities, and I'm going to come down to Game, and I'm going to fill the screen. I'm going to click Add, and I'm going to take this up here. I want to get rid of these. I'm going to click Add. Yep. Won't move. There it goes. I want to get rid of this star. I'm going to click Add. I want to get rid of this star, and I will get rid of some nebulosity, but that's okay. Another, and let's just drag this to include that. Let's also drag this to include that. Include that. Okay, let's make another. Put it over that one. I don't have to be precise. That one. I will be on the next one though. I'm going to take this down. Here, I want this smaller. Okay. All right. Now that we have that, take a look. Let's go ahead and click. We want a gradient mask, so we'll click OK. And here's our mask. So I'm going to take this and drop it on my Luminance mask. We can go ahead and show this. I'm going to bring up curves, and let's go ahead and get a, and I'm just going to drop this down and apply it, and everything went away but this one and this one. Let's apply it again, apply it again, let's apply it again, let's apply it again, and a couple more times. That's good. Okay, so I have eliminated the outlier stars from my nebula, and we can remove this mask, the game mask. We won't use that again. And I'm going to retitle this Nebula Mask, and I will use this again. Okay, we now have two point spread functions, a luminosity mask and a star mask. So let's bring up deconvolution, and let's bring up our luminance layer. I want to pick an area where there's a lot of stars and create a preview. I'm going up here to this shadow box, which is add a new preview, or you can use alternate in, and I'm going to draw a box, and we want to look at this, and I want to get my Luminance Mask, and I want to apply this to the Luminance layer, and I want to unshow it, hide it, so that we have it applied. And the way you can tell is that your tab has turned brown, so you know you have an active mask when that happens, and your preview isn't white, it's kind of a creamed color. Okay, we're going to start off. Oh, we have to go back to de-ringing, and let me give you my settings for deconvolution. I'm going to start out with 50 iteration. I think the default is 50. I'm going to use regularized Richardson-Lucy. You can go back and forth with Van Sittert or Richardson-Lucy, but I think you'll end up here. I do. The target is my luminance layer. The global dark is the one slider that you will spend most of your time adjusting, that plus the local amount. And I'll leave the noise model to Gaussian, wavelet layers to 5, and to the spleen of 5. All these other settings are default. I believe they're default, but these are the settings: 3.3, 1.1.1, 1.1.7.7.7. Convergence is disabled. I've yet to enable that and have a positive result. Dynamic range extension is left to 0. So we need de-ringing. We also need a de-ringing mask. Now, this is already set to pick up the star mask, but if you'll click on this box and the pull down, you can find the star mask and bring it up. This happens to be the small PSF, small caps. We're going to try both, the small caps and the large. You also can experiment with the parametric point spread function, and this is created by PixInsight. If you find that you have some stars that are oblong, you can change the shape of it. You can change the aspect ratio of it, and you can change the rotation of it. So I leave it on 2 when I use it, and that's the default, and it works pretty good. But if you don't use the dynamic point spread function or Hartman-Borman's script, then give this a try. Give it a try anyway. But we're going to use an external point spread function, and we're going to try the one that I created with the dynamic PSF, and that is this one. This is the one we'll be using. This is the one that the script Hartman-Borman created used. And his picked up some of the smaller stars. I tried to get a combination of large and smaller while staying in the Moffett category. Okay, and we have the point spread function, we have the Luminance Mask, and we have our de-ringing mask. So we're ready to try it on a preview. Let's first try 30 iterations. I already can tell you it's not going to work. Okay. Can you see the, hey, I don't know if you can, but there's some artifacts around each of the stars. There you go. So we're not happy with that. Here's a before and after. And if you look at the stars, they become more tighter. Okay, let's raise this up just a little and try it. That's worse. And if we lower it, it's going to be better. But this is the slider you'll play with the most. Okay, that looks good there. And I hope this shows up. This is the before and after, before and after. Let's zoom in. Watch some of these smaller stars. Before, after, before, after. Also look at the background. Before, after, before, after. So I believe we're going to try now 50 iterations. I go as high as 70 iterations when I'm running this script or this process. Okay. Oh yeah, that looking good. Okay, we'll do a before, after, before, after. Now keep in mind, this is the Luminance Layer, and I am in the first stages really of working on this layer, and I'm attacking the stars and some of the texture in the nebulosity. So let's see what it does to one of the larger stars. Before and after we apply it. Before and after we apply it. All right, I'm going to stay with 50 iterations. I usually do. I'm going to go back to my layer, and we're going to execute or apply and let it do its thing. Okay, we're done, and we have applied the point spread function using the point spread function that was created using the dynamic PSF. I was going to show the difference between the one by Hartmut-Bormann, but I think I'm just going to leave it at that. I can already tell you from having used both of them, you'll not be able to tell a difference. So it boils down to, do you want to get involved hand-picking the stars using the dynamic PSF, or do you want Hartmut-Bormann script to do it for you? And for some reason, I am old school enough to want to do this myself. It isn't that I feel uncomfortable using the script. It's just that I have been in the habit of using the dynamic PSF, and I can do it pretty quickly. And actually, I can do it a lot quicker, as the script takes a little while to run, particularly when you have as many stars in the image as my wide field setups do. So I can cut the time by 75% by doing it myself, and that's a big reason. So we have concluded the point spread function. I'm going to remove the mask and delete the mask, and we're going to end this video. When we come back, we're going to finish our work on this Luminance layer as we prepare it for use towards the end of the processing stage with our RGB image. And at that time, we'll bring up the LRGB combination, and we will combine this Luminance mask with our RGB image. So we'll catch you guys later. Make sure that you take a few minutes to find somebody that you can say something nice to, and tip your hat to them, and I know you're going to make their day, and I'll bet you feel better for having done that. With that being said, clear skies, and I'll catch you on the next video.